In the last lesson, we were graphing parabolas, conic sections parabolas, and in today's lesson, we are going to graph circles. So by the end of the lesson, you're going to be able to graph and write equations of circles. The first thing we are going to do is define a circle. A circle is a set of all points which are equidistant from a point called the center. The distance between the center and a point on the circle is called the radius. The distance formula can be used to derive the equations of a circle whose center is the origin. So let's look at this. If I have a coordinate plane, and in the coordinate plane I graph a circle that has a center at the point 0, 0, and another point P which is on the circle, the first thing I can do is find the distance between the point which is 0, 0 and point P. So let's go ahead and do that. So I have a point 0, 0 and I have xy. So to find the distance, I am going to say the distance between these 2 points is x minus 0 squared plus y minus 0 squared. So if I simplify, I simply get the distance will equal to the square root of x squared plus y squared. And if I square both sides of the equation, I end up having the equation of the circle that is centered at the origin. The equation of this circle is x squared plus y squared equals the radius squared. In the first example, we are going to graph the equation of the circle that is y squared equals 4 minus x squared. This equation is not in standard form, so I'm going to first rewrite it in standard form by adding x squared to both sides. So the equation in standard form will be x squared plus y squared equals 4. So the center of this circle is going to be the point 0, 0. So I'm going to graph that. And the radius of the circle will be the square root of 4, or the radius will be 2. So I'm going to take 2 distances away from the center. So I plot a point above, below, to the right, and to the left. And then I am connecting those points to create my circle. In the next 2 examples, we are going to write the equations of the circles with the given information. And I'm going to show you 2 different ways on the first example, and then you can choose whichever method you would like to use. So I'm going to divide my workspace into 2 parts. And in the first part, it says there is an ordered pair negative 2, 5, and this ordered pair is on the circle, and the circle's center is at the origin. Write an equation of the circle. So in the first way, I am going to take the equation x squared plus y squared equals the radius squared, and simply substitute in the ordered pair negative 2, 5 for x and y. So negative 2 squared plus 5 squared equals the radius squared. Negative 2 squared is 4 and 5 squared is 25. So the radius squared is going to equal to 29. Now I can write the equation of the circle, which is x squared plus y squared equals 29. The second method I'm going to use is find the distance between 0, 0, which is the center, and negative 2 and 5. So the distance will equal to the square root of negative 2 minus 0 squared plus 5 minus 0 squared. So the distance between these 2 points is going to be the square root of negative 2 squared plus 5 squared, which is the square root of 29. So the length of the radius is the square root of 29. So radius equals the square root of 29. And now I can write the equation x squared plus y squared equals the radius squared. So the square root of 29 squared is just 29. So either way, I get the same equation. Now we are going to write an equation for the second problem, which has an ordered pair 5, 1 on the circle, and the center of the circle is the origin. So I'm going to use the method what I used first. I am going to say 5 squared plus 1 squared equals the radius squared. So 25 plus 1 will be the radius squared. So the radius squared will equal to 26. Therefore, the equation of the circle is x squared plus y squared equals 26. In our next example, we'll have to write the equation of the line that is tangent to circle x squared plus y squared equals 17 at the point of 1, 4. So the first thing I am going to show you what a tangent line is. So if I have a circle and I draw a line that is tangent to this circle, it will intersect the circle at one point, which is called a point of tangency. So if I were to draw the radius to this point of tangency, this radius would be perpendicular to the tangent line. This is the information we are going to use to write the equation of the line tangent to the circle. So this is my center right here. So the first thing I'm going to do is find the slope of the radius. To find the slope of the radius, I'm going to use the ordered pair 0, 0 and 1, 4. So to find the slope of the radius, I'm going to say 4 minus 0 over 1 minus 0. So the slope of the radius is 4. Now I need the slope of the tangent line that is perpendicular to this radius. So I am going to find the tangent line slope, which is the opposite reciprocal of the slope of the radius. Once I have the slope, all I have to do is use the point 1, 4 to write the equation in the slope-intercept form. So y equals mx plus b. The line passes through the point 1, 4. So 4 will equal to, the slope is negative 1/4 times 1 plus b. So 4 will equal to negative 1/4 plus b. And if I add 1/4 to both sides, 1/4 and 1/4, my y-intercept is going to be 4 and 1/4 or 17/4. So the equation of the line tangent to the circle at point 1, 4 is going to be y equals negative 1/4 x plus 17/4. In this example, we have to write an equation of the line that is tangent to the circle x squared plus y squared equals 20 at the point negative 2 and 4. So I'm going to follow the same process as in the previous problem. The center is 0, 0, and the point on the circle is negative 2, 4. So I'm going to find the slope of the radius as 4 minus 0 over negative 2 minus 0. So that gives us 4 over negative 2 or just negative 2. So now we find the slope of the tangent line, which is 1/2. Now I'm going to use the point to find the equation. So the equation is y equals mx plus b. So I will put 4 equals 1/2 times -2 plus b. And if I simplify, 4 will equal to -1 plus b. And the y-intercept b is going to be 5. So now I can write the equation as y equals 1/2 x plus 5. In this last example, we have to write the equation of the circle in standard form that passes through point 10, 2 and is centered at the origin. So I'm going to follow the same process as we did on the first couple of examples. X squared plus y squared equals the radius squared. So 10 to the second power plus 2 to the second power equals the radius squared. 100 plus 4 is equal the radius squared. And finally the radius squared equals 104. So the equation of the circle centered at the origin is x squared plus y squared equals 104.